Hello, everybody, and welcome to this week's lesson. We are on Unit 6, talking about percents, graphs, and statistics this week. The materials that you'll need today is your welcome packet, pencil and paper, of course. You might find it helpful to have your previous lesson notes with you, and you will probably want a calculator with you today. The calculator on your phone will work just fine. So let's get started with today's warm-up question. I'd encourage you to pause the video right now and give this question a try. It's related to a skill that we started practicing last week. And when you're ready, start the video again and we're gonna go through it together. Okay, so warm-up question. Solve the proportion for the missing value. And it says 12 over 50 equals n over 75. So 12 over 50 equals some number over 75. And we need to figure out what that missing number is. So first of all, what is a proportion? Do you remember what that word means? So a proportion is two ratios that are equal. Two ratios that are equal. And now, of course, the follow-up question to that is going to be, what is a ratio? So ratios are something we've talked quite a bit about over the last several weeks. A ratio is just a comparison of two numbers. So anytime you put two numbers next to each other and you say, here are these numbers, that's a ratio. So comparing two numbers. And in a proportion, we say that the ratios are equal. So for example, if you have done any practice with finding equivalent fractions or simplifying fractions, then you have already gotten a lot of practice with making proportions. If we say, for example, that 2 out of 4 is equal to 1 out of 2, or 2/4 is equal to 1/2, we have made a proportion. We're saying that this comparison over here of 2 to 4 is equivalent or equal to this comparison over here. Okay, now one more thing that we need to remember about proportions is this special characteristic that all proportions have, and that is that if something is a proportion, the cross products will be equal. So when you cross multiply, you should get the same answer for both sets of multiplication. So let's take a look at this example up top here. If we do 4 times 1, 4 times 1 is 4. And then 2 times 2 is also 4. So that's another way we know that this really is a proportion. So we can use that characteristic to help us solve proportions for missing values. We take a look at if we return to this proportion down at the bottom here, first thing we're going to do is we're going to cross multiply. Again, returning to that characteristic that all proportions have, that the cross products have to be equal. So we're going to start by cross multiplying. And we're going to cross multiply with the two numbers that we know. So we're going to do 12 times 75. Okay, and what is 12 times 75 equal to? It's equal to 900. Okay, so now we know that our cross products for this proportion have to be 900. That means that 50 times whatever n is must be 900. So if we know that 50 times something is 900, how can we figure out what that something is? Well, we can reverse our multiplication. We can do a little division to help us find that missing piece. So if 50 times n is 900, that means n will be 900 divided by 50. And so my second step when I solve this proportion is to divide. I'm going to take my result from the first step, I'm going to take my cross product, and I'm going to divide it by 50. I'm going to divide it by the number I haven't used yet. And 900 divided by 50 will give me a result of 18. That means that n, our missing number, is equal to 18. All right, so keep this process in mind because we are going to be using proportions a little bit later in this lesson. All right, so our learning goals for this week. By the end of this week, you will be able to solve real-world problems involving percentages. Some examples of the types of percent problems that you'll see include calculating simple interest, calculating tax, doing markups and markdowns, gratuities and commissions, and percent increase and decrease. So lots of different variations of percent problems. The second learning goal for this week is interpret tables and graphs. So we're going to be talking about the different parts of graphs and tables and what those parts can tell you. And then finally, we will practice computing mean, median, mode, and range of rational number sets. So mean, median, mode, and range of lists of numbers. Now, these skills that we're working on this week, these are also some of the main math skills that show up on the other GED tests. So the science test, you will often see questions relating to percents. You will definitely see a lot of graphs, and you will most likely have some questions about mean, median, mode, or range. And also on the social studies test. So on the social studies test, you will be asked to interpret graphs, and you may need to calculate a mean, a median, mode, or range. So these skills should be helpful for all three of those subjects. All right, so let's dive right into these percents. The word percent literally means per 100. This word cent here, that comes from the Latin word for 100. If you speak Spanish or French or Portuguese, then you should recognize that your word for 100 is very similar to cent. So it might be ciente or cent, right? So this word cent just literally means 100. So when we say something like 75%, we could think of it as 75 per 100 or 75 out of 100. So that means a percent is a comparison to 100. It is a way of talking about a part of a whole. So that means we can add percents to our list of the different types of comparisons that we have talked about, right? So we have learned about ratios, which is just a general word for any kind of comparison of two numbers. We've talked about unit rates, which are a comparison to one. So for example, if you are driving down the road at 45 miles per hour, right, that's the number of miles in 1 hour. It's a comparison to one. We've talked about fractions, which are a special type of ratio where we compare a part to a whole. And now we have percents. Since percents are comparing a part to a whole using the number 100, percents are really just a special type of fraction. Percents are a special type of fraction where the denominator has to be 100. So 75%, it really is the fraction 75 out of 100. So that means that we now have three different ways of talking about parts of a whole. We've got fractions, we've got percents, and what's the third type of number that we have that talks about parts of a whole? Can you think of it? So the third type of number is decimals. So fractions, decimals, and percents are three different ways of talking about the same thing, three different ways of talking about parts of a whole. And I've got an example up at the top here. So we were just talking about 75%. So the fraction 3/4, 3/4, it means the same thing as 0.75 as a decimal, which means the same thing as 75 out of 100 or 75%. So here on the screen, I actually have four different numbers that are all talking about the same amount of stuff. They're all basically the same thing. And so because they're all the same thing, that means that we can learn how to convert between these different types of numbers. And it can be useful to learn how to convert between these different types of numbers because depending on the situation you're in or depending on the problem you're looking at, it might be easier to work with one type of number rather than another. Or you might have a personal preference for what kind of number you like to work with. And so you might want to, for example, like take all of your fractions and change them into decimals when you're working on a problem so that you can just do calculations with decimals instead of fractions. So it's a good skill to have. It really improves your fluency in math. It improves your ability to kind of work quickly and accurately in solving problems. Very much like knowing your times table improves your fluency. It just allows you to work more quickly, more accurately, and makes things a little bit easier on you. So that's what we're going to practice first today. We're going to practice converting between these different types of numbers. And on the screen here, I have written out the processes for converting between the different types of numbers. So let's start with the first one here. Let's say we have a fraction and we want to take that fraction and change it into a decimal. Now this is something we already talked about in a previous lesson. To do that, we would divide. So we divide the numerator, the top number, by the denominator, the bottom number. A fraction is really just a division problem waiting to happen. So when you go ahead and actually do the division, you get a decimal as an answer. So if we have 3/4 and we want to change that into a decimal number, we can just go ahead and do 3 divided by 4. And we will get 0.75 as a result. Now you want to be careful that you are dividing in the correct order here, right? So we're doing 3 divided by 4. We're not doing 4 divided by 3. That's different and it will give you a different answer. Okay, so that is fraction to decimal. Now let's go in the opposite direction. Let's take our decimal number and change it into a fraction. So to take a decimal and change it into a fraction, this process is all about place value. So if you have a decimal number and you want to change it into a fraction, what you're going to do is you are going to figure out the place value of the last digit. So look at the end of your number, what's the place value of that digit? And that place value is going to become the denominator of your fraction. So for these types of problems, for taking a decimal and changing it into a fraction, you really need to know your place values. And in your welcome packet, if you need a little reminder about your place values, in your welcome packet that I get you on the first day of class, you have a place value chart. So you have a place value chart in that welcome packet that you can use to help you for this. So in the case of 0.75, what is the place value of that 5? So the 5 is in the hundredths place. And so we will say that 0.75 means the same thing as 75 hundredths, or 75 out of 100. And that's a fraction. We've just created a fraction. And now, since we're trying to make a fraction, our last step should always be to simplify as much as possible. So we want to think of what's the greatest common factor of 75 and 100? What's the largest number that will go evenly into both? So you might think of 5. 5 will go evenly into both. It's not the greatest common factor though. The greatest common factor is actually 25. So we can divide the top and the bottom of this fraction by 25, and the fraction will reduce to 3/4. And that's good because we knew that was the answer, right? We knew that 0.75 is the same thing as the fraction 3/4. Okay, so that was fraction to decimal, right, is about dividing, and then decimal to fraction is about place value. Now, let's talk about percents. So keep in mind here as we talk through working with percents that a percent is really just a fraction. It's really just a special fraction where the denominator is 100. So to take a decimal and turn it into a percent, what do? We multiply by 100. And a little shortcut for doing that is moving the decimal point 2 places to the right. So anytime you multiply something by 100, you are just moving that decimal point over 2 places to the right. If I have the number 0.75, and I want to write that as a percent, I can take my decimal point and move it over 1, 2, right? I'm multiplying by 100, so I would expect my final answer to end up being bigger than what I started with. You can use that to help you decide like which direction the point needs to go in. So 0.75 will become 75%. And that's decimal to percent. Okay, now let's try percent to decimal, going back in the other direction. So if you have a percent, you want to change it to a decimal, you divide by 100. Now, this is really going back to our fraction rule right here, right? If a percent is just a fraction, to change it into a decimal, we would divide. So we would do the numerator divided by 100, since it's a percent. So if we have 75%, well, 75 divided by 100 will give us 0.75. And again, a little shortcut you can take to help you with that calculation is we are just moving that decimal point over 2 places to the right. Now you might look at 75% and you might be like, well, there's no decimal point there. How can I move it around? You want to keep in mind that when you have a whole number, there is a decimal point. We just don't bother writing it. But it is sitting here invisibly right next to the 5. So here is the decimal point. If I'm dividing by 100, I move it over 1, 2. And so my decimal point will land right next to the 7 here. So I get 0.75. Okay, and then last thing we're going to talk about is taking a percent and changing it into a fraction. We've already kind of touched on that. So 75% just literally means 75 per 100. And so I've made a fraction. So you take that percent and put it over 100 and then reduce or simplify your fraction as much as you can. We actually already reduced 75 over 100. We saw that it's equal to 3/4. Now, you're probably only going to want to take your percent and change it directly into a fraction if your percent's a nice whole number. If your percent includes any decimal stuff in it, you probably don't want to take that percent and change it into a fraction because then you're going to have like a decimal hiding inside of your fraction. It's going to make it trickier to simplify. So if your percent includes a decimal point, you would probably want to change it first into a decimal and then change that decimal into a fraction. That will avoid ending up with any decimal points inside of your fraction. Now, if you don't mind that and you feel confident that you can deal with it, no problem. But I would avoid it. And if you want a little more help with that, just let me know. Okay, so I hope you've taken some notes on these steps here because we are going to get some extra practice with converting between these 3 types of numbers. So converting between fraction, decimal, and percent, I've got a table here with some missing values. So in the first row, I've told you the fraction, and you are going to fill in the decimal and the percent. In the second row, I've told you the decimal. You're going to fill in the fraction and the percent. And in the third row, I've told you the percent, and you're going to fill in the decimal and the fraction. So pause the video. See if you can fill in all of these missing numbers, and when you're ready, come back to the video, we're going to go through this together. So 1/4. How do we turn 1/4 into a decimal? We divide. So we're going to do 1 divided by 4. You could think of it like if you have $1 and you want to split that $1 up amongst 4 people, right? Each person is going to get 25 cents, 0.25. So 1/4 is the same thing as 0.25. Now, what does that decimal look like as a percent? It's going to be 25%, right? Just multiplying by 100, get 25%. All right, next row. We have a decimal of 0.125. Let's change that into a percent first. So if we have 0.125, how do we change it into a percent? We multiply by 100, which is the same thing as moving the decimal point over 2 places to the right. So this will become 12.5%. 12.5%. Okay, and then what about as a fraction? So to take a decimal and change it into a fraction, we look at the place value, right? So the place value of this number is it goes out to the thousandths place. So we're going to write this as 125, right? We drop all the decimal stuff and we just write it as 125 over 1,000. Now we have a fraction, but since it's a fraction, we're going to simplify as much as we can. So what is a number that will go evenly into 125 and 1,000? What is a common factor for them? Well, 5 is a common factor. You might know that if you notice that both of these numbers end in either a 5 or a 0. So numbers that end in 5 or 0 are divisible by 5. If you look at your times table and you look down the 5s column, you'll see that the numbers kind of alternate 5, 0, 5, 0, 5, 0, 5, 0. So that's something you might notice. But we can actually divide by a larger number. 25 is a common factor of both of these. And we can actually go up further than that, and we might find that 125 is a factor of both of these numbers. So 125 will go into 125 once. 125 will go into 1,000 8 times. Now, it's probably not something you would know off the top of your head, but, never be afraid to test it out. Get out that calculator, play around with the numbers and see if you can find a larger factor. So I am going to simplify by 125 here so that I can do it in one step. But if you had chosen to divide by 5 or 25, that's fine too. You'll just have to do a couple of rounds of division. So you will simplify in multiple steps. So 125 divided by 125 is 1. 1,000 divided by 125 is 8. So 0.125 is the fraction 1/8. All right, last row here, we've got this percent, 80%. Let's take that percent and turn it into a fraction. So 80% will become 80 over 100. And now let's simplify. So what's the greatest common factor of 80 and 100? Well, they actually have a bunch of factors in common. So 2, 5, 10, but the greatest common factor is 20. 20 is the largest number that'll go evenly into both. 80 divided by 20 is 4. 100 divided by 20 is 5. So 80% is the same thing as 80 out of 100, or 4/5. Okay, now let's do the decimal. So you could take 4/5 and change it to a decimal, or you could take 80% and change it to a decimal. Let's do 80%. So what does 80% look like as a decimal? Well, 80, we divide by 100, so we move our decimal point over 1, 2. And so we end up with 0.80, 0.80, or we can drop that 0 at the end. We could write it as just 0.8. So 0.8. All right. So now in your homework, you will have some problems where you're practicing converting between these different types of numbers. Again, if you go into your welcome packet, you do have a table there with a list of common fractions and what they look like as percents and decimals. It's the second to last page in your welcome packet. And you can use that table for extra practice if you want more practice with converting between these different types of numbers. You could basically think of this as an answer key, and you want to see if you are able to produce the answers on this table. So you could pick a fraction. Let's say you pick 3/10, and you see, okay, can I turn that into a decimal? You check and see if you got it right. Can I turn that into a percent? You check and see if you got it right. So you can do your own extra practice with that. All right, so now let's use some percents to actually solve some problems, to find some missing information. So one of the most common things that you might do related to percents is you might want to calculate a percent of something. And probably the easiest way to calculate a percent of something is just to divide. So if I say, what percent is like 8 out of 16, you would just do 8 divided by 16, right? So we said a percent is really just talking about a part of a whole. So to calculate a percent, you can take your part divided by your whole. That will give you a decimal number, which you then change to a percent. So let's see with this example here what that looks like. It says there are 20 students enrolled in a class. On Thursday, 8 students attended the class. What percent of students attended? So in this situation, what is the part and what is the whole? Well, there's 20 students in the whole class. And then the part that attended was 8. So 8 out of 20. Now let's divide. So 8 divided by 20 will give you 0.4. That's a decimal answer, right? What we just did was we set up a fraction and we divided to change it into a decimal. So now let's take that decimal and change it to a percent. 0.4 will become 40%. Right, very much like 0.8 was 80%, so 0.4 is 40%. Okay, so that was just a little taste, a little intro of something you might do relating to percents. But now let's talk about all percent problems in general. So in any problem talking about percents where you have a missing piece of information you need to find, there's kind of 2 main strategies that you can use. So one of the strategies is you can set up a proportion and use that to solve for missing information. Or the second strategy is you can use the percent formula to solve for missing information. They both will get you to the same answer as long as you use them correctly. It's really just a matter of personal preference. So, setting up a proportion. Remember, a proportion is 2 ratios that are equal. So in the case of percents, we'd be saying that the relationship between the part and the whole is equal to the relationship between the rate. And here I use the word rate because that's a good word to know. You want to remember that oftentimes rate just means the same thing as percent. So like if you take out a credit card, your credit card has an interest rate. That might be like 24%, right? So interest rate and percent means the same thing. Okay, so the relationship between the part and the whole is going to be equal to the relationship between the rate and 100, or the percent and 100. We can set that up using the information from the last example. right? So we said that 8 out of 20 students attended class, and that was the same thing as 40%. So there we have a proportion. Now all of the information is filled in this proportion. There's nothing left for us to look for. But this is how we could set it up to show this part to whole relationship. Now the percent formula is, it's basically just the proportion but reorganized a little bit. So the percent formula says that the part is the rate times the whole, or the part is some rate of the whole. So, and in this case, if you're using the percent formula, you're going to want to rewrite your percent as a decimal number. That just makes the calculations a little more straightforward when you're multiplying or dividing. So, in the example of the students attended class, we could say 8 is 0.4, right? So 40%, 0.4 times 16. And you can give that a try. If you do 0.4 times 16 on your calculator, you will get 8 as a result. Oh, sorry, it wasn't 16. It wasn't 16, it was 20. I'm just making up numbers over here. Right, so 8 is 0.4 times 20. So here, right, we still have those same pieces we were working with in the proportion. We've got the part, we've got the whole, and we've got the percent. Basically, instead of writing the percent as a fraction, we've written the percent as a decimal. Okay, so when you are dealing with percent kinds of problems, you are going to need to first recognize that it's has to do with percents, so it'll probably say percent or rate in the problem. And then you're gonna need to recognize, okay, what's the percent, what's the whole, what's the part? One thing that can help you with identifying those different pieces of the puzzle is looking for the keyword of. So the keyword of usually comes right before whatever the whole is in the problem. So we would say the part is some percent of the whole. All right, so next we are going to get some practice with identifying the part, the whole, and the percent in each situation here. So in these situations, there's no missing information. I've given you all the information. You are just practicing identifying these 3 important pieces. So, number 1, Dylan sold 40% of the t-shirts in his store. He sold 24 out of 60 shirts. So in this problem, what is the percent? The percent is 40, right? It says 40%, so that should be easy to find. I'm going to start setting up a proportion. The 40% is going to belong over on the right side here with the 100, so 40% is 40 out of 100. And then what is the whole? So the whole in this problem is 60, right? It's 24 out of 60, out of a total of 60. So we've got a total of 60 shirts, and then he sold 24 of them. So 24 is the part. So that's what this would look like if we set up the situation as a proportion. Now let's set it up as let's set it up using the formula. So we would say that the part is 40% as a decimal times the whole. Okay, that's all there is to it. Let's try number 2. In a light bulb factory, 1.5% of the bulbs made are defective. Yesterday, the factory made 600 bulbs and 9 of them were defective. So, set up a proportion first. What's the percent, or what's the rate? The rate is 1.5, 1.5%. What's the whole? The whole is 600. Right, the factory made 600 bulbs and 9 of them, so 9 of the bulbs, 9 of the 600 bulbs were defective. And then the part is 9. Okay, now let's write this using the percent formula. So the part is the percent as a decimal, so 0.015 times 600. All right, and then number 3 here, 8 is 50% of 16. So actually the first thing I'm going to do here, I'm going to do the formula first. We'd say 8 is 50%, 0.5 of 16. Now as a proportion. So our part is 8 and our whole is 16. And then our percent is 50. Okay, so anytime you are in a situation where you're dealing with a percent, there will always be a percent, and there will be a part, and there will be a whole. Now, when you are working on a percent kind of problem, what you're probably going to be doing is you're going to be solving for one of those pieces that are missing. And that's what you would either use the proportion for or you would use the formula for. So let's try these practice problems here, which have a piece of information we need to solve for. Number 1, it says Carmen earned $550 in commission on $15,900 in sales. What is her rate of commission? Keeping in mind that rate and percent mean the same thing. All right, well, what is the missing piece in this problem? What's the thing that we are supposed to solve for? Well, it says, what is her rate? So what is the percent? The percent is the thing that's missing. So in my proportion, I'm just going to put a little r here for rate. You could put X or N or question mark or smiley face or empty box, whatever it is. It's just a little placeholder for that missing number. And then the part and the whole, so the part is going to be 550 out of a total of 15,900. Okay, so we've set up our proportion and now we can solve it just like we practiced at the beginning of the lesson. So I'm going to cross multiply 550 times 100. And that will give me 55,000. So I know that for this proportion, the cross products are 55,000. That means 15,900 times whatever R is has to be 55,000. So to find what R is, I'm going to take that cross product, 55,000, and divide it by 15,900. So divide it by the number we haven't used yet. And you should get 3.459 something, something, something. You get this decimal number. So let's round this to the nearest 1/10 of a percent. So rounded to the nearest 1/10 of a percent, this will become 3.5, 3.5%. So that means that R is 3.5%. Okay, so that was solving this problem using the proportion. Now let's try this with the formula. So the formula says that the part is equal to the rate as a decimal times the whole. So how would we solve for the rate? We would divide. The rate will be the part divided by the whole. So already this is starting to look really similar to that proportion that we just set up, right? Because the proportion was 550 over 15,900 equals our percent. So we basically have the same thing. 550 divided by 15,900, that will give you your answer as a decimal. You'll get 0.03459 something, something, something. So now we want to take this decimal answer and change it into a percent. And let's round it off to the nearest tenth of a percent like we did with the first strategy. So we'll say that this is about 3.5%. So her commission, she gets about 3.5% of the sales that she makes. So we just solved the same problem in two different ways. And the way that you choose is up to you. I think each way kind of has some good things about it. So the proportion, I think, is nice because a proportion is a multi-purpose tool, right? You can use proportions for percent problems, but you can also use proportions for any problem where you're making a comparison between two things and you need to solve for missing information. So it's not just for percents, it's for anything involving comparisons, really. So a proportion is nice because it's a multi-purpose tool. I also think it's nice because it kind of emphasizes the part to whole relationship that's important when we're talking about percents. On the other hand, the formula is nice because once you get the hang of it, I think it can really make your calculations more efficient. So once you've done a lot of practice with the formula, you might look at this problem and see, oh, it's asking me to calculate a percent. So I'm just going to divide. I'm going to do the part divided by the whole. That gives me a decimal, which I then turn into a percent. So once you get the hang of the formula, it can make your calculations a little bit quicker. All right, so let's try number 2 here. It says Neva's car is now worth $15,000. This is 80% of what she paid for it. How much did she pay for the car? So first thing, let's think about what piece of the puzzle are we missing here? What's the thing we need to solve for? Well, it says how much did she pay for the car? That's 80% of what she paid for it. So we don't know what that is, right? And that's going to be the whole. Because what it's worth now is 80% of what she paid for it. We can use that keyword of to help us out. So we're missing the whole in this situation. So I'm going to set up a proportion. The whole is missing, so I'll just put a W there. The part will be the 15,000. And then the percent is 80. And now we solve. So 15,000 times 100 is going to give you 1,500,000. You'll have 5 zeros. And now we divide. So we take that 1,500,000, divide by the number you haven't used yet, divide by 80. And you should get, hold on, let me double check here. Right, we get 18,750. So we would be saying that she paid $18,750 originally for her car. Which sounds reasonable, right? She originally paid $18,750 and now it's a couple years later, so her car is worth a little bit less. Now it's only worth $15,000. Now I will set up the formula here, and I will challenge you to try solving this problem using the formula and see if you can arrive at the same answer. So the part is 80% of the whole. So there's the formula all set up. See if you can do the calculation that you need to do to arrive at the same answer of 18,750. Okay, so next thing we're going to talk about is a particular type of percent problem that you might encounter, which is percent change or percent increase and decrease. So this is also sometimes called percent change. So when we're talking about percent increase or decrease, what we're doing is we are comparing the amount of change, so the amount of increase or the amount of decrease, to the original amount. So it's really just a special type of comparison that we're making. So in order to make that comparison, the first thing you would need to do in any kind of percent increase or decrease problem is you would figure out the amount of increase or decrease. You would need to subtract to find the change. So from there, you really could solve the rest of the problem either by setting up proportion or using the percent formula. So if you were using the percent formula, what you would end up doing is you would take the change compared to the original amount, so the starting amount. Basically, you're setting up a fraction here, a part to whole relationship. So you could divide. That will give you a decimal answer. And so your final step would be to take that decimal and change it into a percent. So let's look at this example here. A jacket is on sale for $90. 4 days ago, it was priced at $120. By what percent was the price reduced? So by what percent did the price decrease or go down? So first thing we do is we figure out how much did it go down. So 120 minus 90 gives us 30. And now we want to compare that to the original amount. So originally the jacket was $120. 30 divided by 120 will give us 0.25, which is 25%. So 30 is 25% of 120. You could also set this up as a proportion if you'd like. So you could say 30 over 120 equals some percent over 100. And then you would cross multiply and divide. You would get 25 as your final answer. You might also, another way you could think of this is you might see that fraction 30 over 120, and you might see, oh, well, this will reduce. If I simplify this fraction all the way down, it will reduce to 1/4. And I know that 1/4 is 25%. So that's another way that you could arrive at your percent. Okay, let's get some practice with that. So take a look at this problem, read through it, and then give it a try. When you're ready, come back to the video. We're going to go through it together. So it says, tire sales usually decrease for all road tires during the summer months. Looking at the graph, what was the percent decrease in sales from July to August? So from July to August, we are looking for the percent decrease. So looking at the graph, in July, the sales were $300. Oh, sorry, there were 300 sales. And in August, there were 100 sales. So from July to August, the sales decreased 200, keep saying dollars, it's not dollars, it's just number of sales. The sales decreased by 200. And now we want that as a percent. So we're gonna take our 200 and compare it to the original amount, compared to the whole. 200 divided by 300 will give you a decimal of 0.6 repeating. You'll get 0.66666666666, and it'll probably have a 7 at the end just because your calculator is rounding off at the end of its screen. So here's a decimal answer. Let's change it into a percent. It's going to become 66.666666666%. Now, usually when we're talking about percents, we don't give repeating decimals as a final answer. So we would probably round this off. We would round this off. You could, since the problem doesn't give you specific instructions on how to round, it's up to you. Let's round this to the nearest percent, the nearest whole percent. So looking here at my ones place, I look to the left, look to the right, I see a 6. That tells me to round up. So this would become 67%. So sales went down by about 67% from July to August. All right, so now let's wrap up the percent talk here with just a couple extra practice problems. So number 1, from 2000 to 2010, Kentucky's population increased by 301,175. This is 7.4% of the 2000 population. What was the population in 2000? Okay. So you've got this amount that it went up. It says this is 7.4% of the 2000 population. What was the population in 2000? So I see this is a percent kind of problem. Right away, I'm going to start thinking about setting up a proportion. So in this problem, do we know the percent? Yes, we do. It's 7.4. Do we know the part or do we know the whole? So in this situation, we know the part, we do not know the whole. The whole is the thing that's missing. And the thing that might help you figure that out is this sentence here, where it says this is 7.4% of the 2000 population. So we're saying that 301,175 is 7.4% of the whole, or of the 2000 population. So the whole is the thing that we're missing. So I'll put W down here for whole, and the part is 301,175. Now I have a proportion and I can solve it. So we're going to cross multiply 301,175 times 100. That's going to give you, what, 30,117,500. And then you're going to divide that by 7.4. So I'm going to go ahead and do that calculation. 301,175 times 100 equals 30,117,500 divided by 7.4 gives me 4,069 9, 3, 2. And then I do get a decimal at the end. I get 0.432, but since we're talking about people, I'm going to round this off to the nearest whole person because we don't want any leftover parts of people. We just want whole people here. So rounded to the nearest whole number, that would be 4,069,932. So the population of Kentucky, based on this information, we could say the population in 2000 was 4,069,932 people. All right, let's try number 2. Kentucky charges 6% sales tax on purchases. If a laptop costs $175, how much will you pay in tax? So in this problem, I look at it, it's a percent kind of problem. I see I've got this total cost of my laptop here, and I'm asked to figure out the tax. So what is the missing piece? Are we missing the whole, the part, or the percent? So in this case, we are missing the part, right? The amount you pay in tax is going to be some small part of the total price. So I'm going to set up a proportion. I'm missing the part, so we'll say P for part. I know I've got 6%, 6 out of 100, and then the part, the tax, out of a total of $175. Now we solve. So we're going to do 175 times 6, and you'll take whatever that answer is, and you will divide it by 100. So 175 times 6, that gives us 1,050, divided by 100, gives us 10.5. Since we're talking about money here, we're talking about the amount of tax we're going to pay, the amount of sales tax. We will rewrite this as money. So this will be $10.50. So if you buy a $175 laptop, you will pay $10.50 in taxes. So what would your total cost then be? When you actually go to check out, you've got your laptop with you, what are you actually going to have to pay? Well, you're going to have to pay $185.50. All right, so next thing we're going to talk about is we're going to talk about working with tables and graphs. So interpreting or understanding tables and graphs. A few pieces of vocabulary here. So you might hear the word data when we are talking about tables and graphs. Data is just another word for facts or information. A lot of times it involves numbers, but it doesn't have to. Data really just means information. Okay, and then a table is just a way of organizing data where we organize it into columns and rows. So columns are what goes up and down. So columns are vertical and rows are what goes side to side. So rows are horizontal. So I have an example in the top right corner here of a table. What I actually did was I just took the data from this graph that we already worked with. I took that data, so I took each month and then the number of sales for each month, and I just changed it into a table. So same data, just written as a table. Okay, and then we also use graphs. So graphs are another way of organizing data, and it's a more visual way of organizing data. There are a few really common types of graphs. These are types of graphs that will almost assuredly show up on your GED math test, also your social studies test, also your science test. So you want to be on the lookout for these. So these three common types of graphs are bar graphs, line graphs, and circle graphs. Another name for circle graph is pie chart. So you might hear them called pie charts. I'm going to call them circle graphs because it's almost time for me to eat lunch and I'm very hungry. I don't want to talk about pie right now. So we've got bar graphs, line graphs, circle graphs, just visual ways of organizing data. The way that the type of graph that you would choose for your data will just depend on like how you want to present your data and what you want to emphasize about your data. So bar graphs are useful for showing values that fall into different categories. So bar graphs really emphasize the amount of stuff you have in different categories. So I just took that same graph from the other page and put it right here, right? We've got our sales split up into different categories. So they're split up into months. And so you can see it's kind of like we got 4 different buckets here, and you can see how full each bucket is with sales. And then we have line graphs. So line graphs are very useful for showing change, often over time. So line graphs are really used for emphasizing like increase and decrease over time. So I actually took, again, the same data, the same monthly sales data, and I rewrote it as a line graph here. So you can see your eye is really drawn to this downward trend in sales, right? The line really emphasizes that decrease that happened over time. And then finally, we've got circle graphs. So circle graphs are good for showing how a total is broken up into different parts or different categories. So here again, we have the same exact data, broken up by month, and it's all fit into a circle. So you could think of the whole circle as like your summer sales, like how much sales you made during the whole summer, and then each little slice represents the different months. Now, if I had done a more thorough job here, I would have labeled each slice so that you could tell which slice went with which, but the smallest slice we know is going to be August. And then the next smallest slice should be July. And then honestly, I'm having trouble telling the difference here between the blue and the orange. So one of these will be May and one of these will be June. That's why it's important to label your graphs. But this was just meant to be a quick example where you just kind of get the idea of what a circle graph is good for. Okay, so now let's dive in a little deeper to the different parts of a graph. So the different things you want to be on the lookout for when you have a graph in front of you that you're trying to understand. So when you are first presented with a table or a graph, what is most important are your close reading skills. So your ability to look carefully at it and to retrieve the important information. So you're always going to want to look for a title. You know what a title is, right? A title gives you a short explanation of what you're looking at. It should be kind of like the main idea of the graph. You want to be on the lookout for a legend or a key. So it could be called either thing. The legend gives an explanation of any different colors or symbols that are being used in the graph. Maps also will often have legends or keys. Like if you ever go, if you go hiking at a state park and you have a map with you, right in the corner somewhere, there will be like a little explanation where they tell you what like the different colored trails are, or they'll tell you like the little picture of a tent means a camping site, stuff like that. You also want to be on the lookout for the source. So the source explains where this information came from. So if you are making a graph and you are getting your information from somewhere, you should state where you got that information from, because if it's not yours, you need to give credit to whoever gave you that information. The source can also help you decide, like, is this information reliable, right? So is it a source that you recognize? Is it a source from somewhere that they seem like they would probably know what they're talking about, right? So paying attention to the source can help you evaluate your information, decide if you should trust the graph or if you need to do a little bit more digging. And then if we're talking about a bar graph or a line graph, you will have two axes. So you will have a horizontal axis or an x-axis, and you will have a vertical axis or a y-axis. The two axes show what are the two things that are being compared in the graph. So again, we're still talking about comparisons here. We've been talking about comparisons all lesson long, right? So comparing two things. And then for your axes, you should be on the lookout for labels. So the labels should tell you what each axis is showing. So for example, in this graph here about our tire sales, we've got a title, number of tire sales per month. And then my horizontal axis, my x-axis, I look at the labels here and I see that the labels are months. So here I've got the months. And then on my vertical axis, I see I've got 600, 500, 400, blah, 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 blah. Those are the number of sales, right? So I could explain this a little bit more. I could say that this is number of sales. So this graph, the two things that are being compared are the months with the number of sales. Okay, so now let's get some practice with identifying these different parts of a graph with this graph here. So first thing we want to identify is the title. What is the title of this graph? So you want to look for something that usually it's going to be either at the top of the graph or at the bottom of the graph, and it'll seem like it's kind of giving you a short explanation of the whole graph, so sort of stating the main idea. So for this graph, the title is right here. Now they didn't do a great job of emphasizing the title of their graph here. It's in that small text. It doesn't jump out at you. So in this case, you might need to, look closely to figure out that that's the title. But sometimes the title will really jump out at you. Like in this graph here, right? Number of tire sales per month. It's big. It's at the top of the graph. It seems pretty clear that that's the title. Okay, so the title of this graph is Kentucky Income by Educational Attainment for people 25 and older. So that's what we're talking about here. Now, let's see if we have a legend or a key. So we do, right here, we have the legend or the key. We'll call it the key because it's shorter. So this right here is explaining what these blue bars are on this graph. So it's giving an explanation for this blue color on the graph. Remember, legends will usually be explaining either colors or symbols that are being used on the graph. So it's telling us that the blue bars represent annual unemployment rate for the year 2016, right? We know we're talking about Kentucky specifically. Okay, so we got the title, we got the key. Let's find the source. So what is the source of this graph? Well, it says source right here. So the source is the 2016 American Community Survey, which is part of the US Census Bureau. And then it says February 2018. That just means that's the date when this information was accessed on their website. So whoever made this graph, they went on the US Census Bureau's website in February 2018 to get this information. But the information itself is about 2016. By the way, the US Census Bureau's website is publicly available. You can just Google US Census Bureau. You will get to their website and you can dig around in all of their information. They've got like population information for decades and decades and decades. And yeah, you can go in there. There's lots of graphs and tables. You can just play around. It's publicly available, so it's really there for you to look into if you're interested. And then I actually, down here in the bottom left corner, I put my own source, right? Because I did not make this graph. I got this graph from the Kentucky Higher Education Authority. So I got it from their website. They have a little flyer about how income and education are related to each other. So that's where I got this from. Okay, so next, let's take a look at our two axes, and let's look for some labels here. So the horizontal axis, what information is the horizontal axis giving us? Well, the horizontal axis is about education level or education attainment, right? So it starts with high school, but no diploma. So people who attended some high school. And then we've got high school graduate, some college, associate's degree, bachelor's degree, master's degree, doctoral degree, and professional degree. So we've got these different levels of educational attainment. That's what the horizontal axis is telling us. And then what about the vertical axis? So we see these dollar amounts. These dollar amounts should be our income, right? So income. So how much people are making in a year on average. This is the average income for people in each of these categories. And then this graph is kind of interesting because it's actually got three different things that we're comparing, right? We've got education level, we've got income, and then we actually also have the unemployment rate. That's what those little blue bars are for, right? So we've got three different things going on here. So these stacks of money are showing us the income for each education level. And then just so that we get the exact numbers, they've actually included the exact numbers down at the bottom here. So again, it all just kind of comes down to you making choices about how you want your information displayed. Okay, so what I would like you to think about, I'd like you to take a look at this graph now that we have gone through and kind of picked it apart and talked about all the different pieces. What are some things that you notice about this graph? This graph is telling you about education, income, and unemployment. What are some things that you notice? So some things that I notice when I look at this, I notice that as we move up in the amount of education, I see that the average income is also going up, right? So the more education you've had, the more money you're likely to earn. I also notice that unemployment is highest for if you don't have your high school diploma, right? And then it goes down as we go up in education. So those are the two like trends that I see when I look at this graph. Let me ask you this. Do you think that this graph would look different if we remade it now, right? So this graph is showing us information from 2016, that's 4 years ago. Would this graph look different if we remade it today, given all of the stuff that's going on in the world right now? What do you think would look different? So what jumps to mind for me is that I know right now, right, the unemployment rates are very high. Many of people have lost work due to what's going on in the world right now. So if I was looking at this graph for 2020, I would expect those unemployment rates to be very different from what they are in the graph. And I might also expect the income to look a little different. Maybe it would be a little bit higher on average just because it's a few years later, so your income tends to increase very slightly with inflation each year. Or maybe average income would be lower just because, again, the job market is stressed, the economy is stressed, so maybe average incomes would be a little bit lower. Or maybe there'd be no change at all. I'm not sure. That's something that we'd have to do a little bit of digging about. Maybe we could find some current unemployment rates for Kentucky. Okay, and then the last thing we're going to talk about today, very last thing, is mean, median, mode, and range. So these are all a part of statistics. So a statistic is basically a piece of information about a group of numbers. So for example, the average student age at a school, that would be the example of a statistic for our purposes. And these statistics that we're going to talk about are measures of central tendency. So mean, median, mode, and range are all about kind of talking about like the average or the most common value in a set of information. So first measure let's talk about is the mean. So mean is also sometimes called the arithmetic average, the average. And the way that we calculate the mean of a list of numbers is we add all of the numbers and then we divide by the number of numbers. So if you wanted to know the average or the mean age of students at a school, you would add up all the ages of every single student and then you would divide by the number of students. The median is the middle number. So, you know, like when you're driving down the highway and that like strip of land between the two different directions on the highway, that strip of land is called the median. It's because it's in the middle, right? Median means middle. So the median is the middle number. To find the median, you would first put the numbers in your list in order, right? Because they need to be in order. They can't just be in a random order. So from least to greatest. And then you would find the middle number. Now, if you have an even number of numbers, you're going to find that there's actually two middle numbers. But the median isn't two numbers, the median is just one number. So if there are two middle numbers, what you do is you would find the mean of the two middle numbers. So you find what's in the middle of those two middle numbers. For example, let's say we wanted to know the mean of we wanted to know the median of 1, 2, 3, and 4. Well, here, 2 and 3 are sharing the middle. And so to find the actual median, we would pick the number that's exactly in the middle of 2 and 3, and it's 2.5, but if you weren't sure, you would add up the numbers, you would find the mean, and then you would divide by the number of numbers. So you'd get 5 divided by 2, which is 2.5. All right, and then finally we have mode. Mode is the number that occurs most often. So mode shows up the most. If each number occurs once in your list, there's no mode. And if there's a tie, then you have multiple modes. Finally, the range. The range is just the difference between the highest and the lowest numbers. So you figure out what's the highest number on my list, what's the lowest number on my list, and then you subtract. Let's get some practice here. So I have a table here where we have age in years, and then we have students. And it looks like maybe this is maybe a daycare or a preschool that we're looking at. So I've got 3 students who are each 2 years old. So AJ is 2, Bobby is 2, and Clive is 2. I've got 1 student who's 3, so Trey is 3. I've got 3 students who are 4, so Tom is 4 years old, Sarah is 4 years old, and Maria is 4 years old. And then I've got 4 people who are 5 years old. So Chris is 5, Lee is 5, Cho is 5, and Nikki is 5. Okay, so we're gonna calculate the mean, median, mode, and range for this group of students. Let's do the mean first. So we are going to add up the ages of all of the students. So 2 plus 2 plus 2 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5. Now you could take a little shortcut there and you could multiply. So you could say 3 times 2 plus 3 plus 3 times 4 plus 4 times 5. But if you want to take it slow, you can just add up each individual number. So I'm going to go ahead and add these up. And I get 3 times 4 plus 4 times 1. Okay, I get 41 when I add up all of these numbers. I hope you also got 41. I'm going to do it one more time just to make sure I typed in my numbers right. So 2 plus 2 plus 2 plus 3. $41. Yes, it is 41. Okay, and now the second step is to divide. So I divide by the number of numbers in my list. How many students do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 students. So 41 divided by 11. So we get 3.72 repeating, right? I'm getting 3.72, 72, 72, 72. So 3.72 repeating. Let's just round that to the nearest 10th. So that will round to 3.7. So the mean age of these students is 3.7 years old. Okay, now let's do the median. So we're gonna write out all of our numbers in order from least to greatest, which we already kind of did with the addition there. We've got 2, 2, 2, 3, 4, 4, 4, 5, 5, 5, 5. Okay, and then we need to find the middle number. So I'm going to kind of cross off numbers as I go to get to the middle. 2 and 5, 2 and 5, 3 and 5, 4 and 4. So this 4 is in the middle here. So the median so the mean was 3.7. The median is 4. So with some lists of numbers, sometimes your mean and median might be exactly the same. Sometimes your mean and median might be very close. And sometimes your mean and median might be very different. It all depends on what numbers are in your list and kind of how they're distributed. So if they're all kind of distributed equally around a middle number, then your mean and median will be very close. But if you've got like just a few numbers that are low and maybe like a couple really high numbers, your mean and median might start getting farther apart. So sometimes they will be the same, sometimes they will be very close, and sometimes they will be very different. Okay, let's do mode next. So the mode is the number that shows up most often. So in our list, what is the age that shows up the most? the age that shows up the most is 5 years old. We have 4 students that are 5 years old. None of the other categories have as many students. All right, and then finally, let's do our range. So the range is the highest minus the lowest. So the oldest ages of our students here is 5. The youngest is 2. 5 minus 2 is 3. So the range is 3. And that's mean, median, mode, and range. I think once you get the hang of it, actually figuring out what the median is, or the mean, or the mode, or the range is not too bad. Like the calculations you're doing, it's not too complicated. The hard part, I think, is remembering what each one means when you sit down and take your test. So you want to really take your time with these, practice them, make sure that you can remember the process for each of these different terms. Okay, and that is all I have for you this lesson. That was quite a bit of material we just covered, so I hope you're feeling ready to go and ready to practice all of these skills. Your homework for this week, you've got a problem of the day from September 28th. You've got your Tuesday review from September 29th, and that Tuesday review goes over skills we've learned about in previous units. And then you've got your worksheet Wednesday, where you will practice all of these skills that we just worked on in this lesson. Thank you all for joining me for this lesson. If you do have questions, please get in touch with me on Remind or email or by phone. I hope you're all having a great week, and I will be talking to you again very soon. Take care.